Let me continue to read the book by Lee Smolin, Einstein's Unfinished Revolution, The Search for What Lies Beyond the Quantum. This is an introduction, and this is the second part. Broadly speaking, the people who aim to address the mysteries of quantum mechanics fall into two classes. The first group assumes that the theory, as it was formulated in the 1920s, is essentially correct. They believe the problem is not what quantum theory, it is instead with how we understand it or speak about it. This strategy to mitigate the strangeness of quantum mechanics goes back to some of the founders, beginning with Niels Bohr. Niels Bohr was a Danish physicist who, while still in his 20s, was the first to apply quantum theory to atoms. As he grew older, he became the de facto leader of the quantum revolution, partly due to the attractiveness of his ideas and partly because he educated and mentored many of the young quantum revolutionaries. The second group has concluded that the theory is incomplete. It cannot be made sense of because it is not the whole story. They seek a completion of the theory that will tell us the rest of the story, and by doing so, resolve the mysteries of quantum mechanics. This strategy goes back to Albert Einstein. More than anyone else, Einstein was responsible for initiating the quantum revolution. He was the first to articulate the dual nature of light as a particle and a wave. He is by now better known for his theory of relativity, but his Nobel Prize was for his work on quantum theory. And he himself admitted that he spent much more time on quantum theory than on relativity. Yet, even if he initiated the quantum revolution, Einstein did not become one of its leaders, because his realism required that he reject theory as it was developed in the late 1920s. In the language introduced in the preface, those in the first group are mostly anti-realists, realists, or magical realists. Realists find themselves in the second group. Those who argue for the incompleteness of quantum mechanics point to the fact that in most cases it can only make statistical predictions for the results of experiments. Rather than saying what will happen, it gave probabilities for what might happen. In a letter to his friend Max Born in 1926, Einstein wrote, quote, "Quantum mechanics is certainly imposing, but an inner voice tells me that it's not yet the real thing. The theory says a lot, but does not really bring us any closer to the secret of the old one. I, at any rate, am convinced that he is not playing at death." End quote. Einstein was also friends with Niels Bohr, and their divergent response to quantum mechanics fueled a passionate debate between them that lasted more than 40 years, till Einstein's death. It continued between their intellectual descendants to this day. Einstein was the first person to clearly articulate the need for a revolutionary new theory of atoms and radiation. But he was unable to accept that quantum mechanics was that theory. His first response to quantum mechanics was to argue that it was inconsistent. When that failed, he argued instead that quantum mechanics gives an incomplete description of nature, which leaves out an essential part of the picture. I believe that Einstein was unable to accept quantum mechanics as a definitive theory because he had exceedingly high aspirations for science. He was driven by the hope of transcending subjective opinion and discovering a true mirror of nature that exhibits the essence of reality in a few timeless mathematical laws. For him, science aimed to capture the true essence of the world, and that essence is independent of us and can have nothing to do with what we believe or know about it. Einstein, of all people, must have felt he had the right to demand this because he had achieved it in his discovery of special and general relativity. Having laid the groundwork for quantum physics, he sought to capture the essence of the atomic world in a complete description of atoms, electrons, and light. Bohr replied that atomic physics required a revolutionary revision in how we understand what science is, as well as in our conception of the relationship between reality and our knowledge of it. This stemmed from the fact that we are a part of the world, so we must interact with the atoms we seek to describe. Bohr asserted that once we absorbed this revolutionary change in our thinking, the completeness of quantum mechanics would be unavoidable, because it was built into our being participants in the world we seek to describe. From Bohr's perspective, quantum theory is complete in the sense that there is no more complete description of the world to be had. If we refuse these philosophical revolutions and insist on maintaining an old-fashioned, common-sense view of reality and its relation to our observations and knowledge, we have to pay a different kind of a price. We have to contemplate that we are wrong about some aspect of nature. We have to find out which common assumption is wrong and replace it with a radically new physical hypothesis that opens the way to a new theory that will complete quantum mechanics. Thanks to a combination of a theory and experiment, starting with a paper by Einstein and two collaborators in 1935, we know one aspect of this completion. The new theory must violate the commonplace assumption that things interact only with other things that are near them in space. This assumption is called locality. A big part of the theory I will be telling in later chapters is how this common sense idea must be transcended in the theory, which will replace quantum mechanics. This book has three purposes. First, I want to explain to lay people just what the puzzles at the heart of quantum mechanics are. After more than a century of studying quantum physics, it is remarkable that there continues to this day to be no agreement on the solution of these puzzles. But having explained the reasons for the debate in a way that is fair to both sides, I will not stay impartial. In the great debate about whether quantum mechanics is the last word or not, I side with Einstein. I believe that there is a layer of reality deeper than that described by Bohr. which can be understood without compromising old-fashioned notion of reality and our ability to comprehend and describe it. Thus, my second purpose is to advocate a point of view about the puzzles of quantum mechanics. This is what the problem can be resolved only by progress in science, which will uncover a world beyond quantum mechanics. Where quantum mechanics is mysterious and confusing, this deeper theory will be entirely comprehensible. I can make this claim because we have known since the invention of quantum mechanics how to present the theory in a way that it dissolves the mysteries and resolves the puzzles. In this approach, there is no challenge to our usual beliefs in objective reality, a reality unaffected by what we know or do about it, and about which it is possible to have a complete knowledge. In this reality, there is just one universe, and when we observe something about it, it is because it is true. This can just be called a realistic approach to the quantum world. An anti-realistic approach describes the mysteries of quantum mechanics to subtleties having to do with how we gain knowledge about nature. Such approach have radical proposals to make about epistemology, which is the branch of a philosophy concerned with how we know things. Realist approach assume we are able to arrive sooner or later at a true representation of the world, and so are deliberately naive about epistemology. Indeed, realists are interested in ontology, which is the study of what exists. By contrast, anti-realists believe we cannot know what really exists. Apart from our representation of the knowledge we have of the world, which is gained only through interacting with it. So I will endeavor to reassure readers that quantum mechanics can be understood completely within a realist perspective in which the external world can be completely comprehended as independent from us. There is no mystery effect of the observer on the observed. Reality is after there, recalcitrant to our will and the choice we make. That reality is fully comprehensible, and that reality consists of a single world. The existence of this realistic approach of quantum mechanics does not by itself mean that the philosophically more extravagant proposals are wrong, but it does mean that there is no strong scientific reason to believe in them, because realism is always to be preferred in science when it can be achieved. Why then is so much of the talk about quantum theory inspired by the weirder ideas in which reality depends on our knowledge of it, or there are multiple realities? This is a problem for historians of ideas. One such historian, Paul Fuhrman, has tried the dominance of Bohr and Heisenberg's anti-realistic philosophy within the scientific community in the 1920s and 1930s to the embrace of chaos and the irrationality advocated by Spengler and others in the wake of the First World War. That history is fascinating, but it is for scholars to do justice to it. I'm not a scholar, I'm a scientist. And this brings me to my third purposes in writing this book. I've been on Einstein's side in the search for deeper but a simpler reality behind quantum mechanics since first reading him on the subject as high school dropout. My journey in physics began when reading Einstein's autobiographical notes, where in the last few years of his life in the 1920s, he reflected on the two main tasks he felt were left incomplete in physics. There were to make a sense of quantum physics, and after that, to unify the new understanding of the quantum with gravity, by which he meant his general theory of relativity. I recall thinking that maybe I could try to help. I was unlikely to succeed, but perhaps here was something worth striving for. After, as it were, getting my mission from reading Einstein's autobiography notes, I found that book by de Broglie talked my way into a good challenge, found great teachers, and got lucky several times in my applications for graduate school and beyond. I'm having a wonderful life, and as a scientist on the frontier, I have had many chances to take a shot on goal, aimed at solving Einstein's two big questions. I haven't succeeded, at least so far. Very unfortunately, neither has anyone else. At the same time, over the past several decades, there has at least been progress toward understanding the problem. This is not nearly as good as it would be to solve the problem, but neither is it nothing. We know much better now that Einstein did the obstacle, that a theory that transcends the limits of quantum mechanics must overcome. And because of that, some very interesting proposals and hypotheses have been put forward, which may frame the deeper theory for which we search. I've been thinking about the question of how to go beyond quantum mechanics since the mid-1970s, and I have never been more excited and optimistic about the prospects of that success. So this is my third reason for writing this book, which is to bring to a wider audience a report from the front in our search for the world beyond the quantum. Let me finish here.